the pleasure of introducing quite a few things, so I actually can go a little bit more directly into the story. So I literally have taken off a couple of slides just before. So Dr. Omar already mentioned differences between the innate and the adaptive. And you already put in the components when you talk about the adaptive immune system, where you have the humoral side and then you have the cell-mediated side. So within the cell-mediated, I'm going to be focusing on that bit, and though I might touch up on a few other components, but only because obviously the immune system works in concert. But again, thank you, Dr. Ahmad, for introducing quite a few things. So since I'm going to be talking mostly about T cells, what do they do? So T cell lymphocytes recognize antigenic peptides of potentially intracellular microbes that are displayed on surface of infected cells, or in the case of transplantation, potentially directly recognizing non-self MHC molecules. And in addition to its importance, obviously, in fighting off infection and pathogens, it is also important in allograft rejection, anti-tumor immunity, and if something goes wrong, it can also be involved in autoimmunity. All right, so it is, I'm reiterating a couple of things from Dr. Omar. So we've already mentioned how you have this CD4 positive T helper cells and the CD8 positive T cells, in addition to the fact that he also mentioned the T regulatory cells. So I am reiterating the fact that the CD4 T helper cells do have multiple types in their own. I didn't go into details for time, but it does include T helper 1, 2, 17, and there are follicular cells, and there are quite a few. But in the context here, we're actually going to be more, when mentioning, it's going to be either Th1 or Th2, depending as we go along in the course. And the CD8 positive cytotoxic T lymphocytes, these are the ones that can cause direct destruction, unlike the T helper cells that are absolutely necessary, but do not cause damage on their own, but rather help a plethora of other cells to function. Okay, so what the location of the pathogens, or the danger, let's call it, dictates the type of cell-mediated immune response. So if you have an extracellular pathogen or a foreign cell, you're going to go through the MHC class 2 pathway. I do apologize for not going to introducing the MHC, but I think you guys are going to have a talk later that will be talking in more detail in that response. So in the more general sense, extracellular relates to MHC class 2 that is recognized by CD4 positive cells, as opposed to intracellular pathogens, foreign cells that are, it can also, oops, actually this is supposed to be class 1, it's a typo, or well, in this case, class 2 and Th1 response. And this is what we talked about when you start producing the cytokines that activate other immune cells. And if it also have MHC class 1, which is present on all nucleated cells, and it has the capacity to be recognized by CD8 positive T cells. When we have viruses, and I've added here foreign APC in the context of transplantation, that would undergo the MHC class 1 pathway that's recognized by CD8 positive cytotoxic T lymphocytes, and that would eventually end up killing the infected cell. Or if it's when I say foreign APC, let's call it potentially the donor APC that's considered as foreign, that would be eliminated. As Dr. Ahmad mentioned about the spleen, so if you have immune responses to antigens that are found in the blood, the immune response tends to be initiated in the spleen. When your body is responding to pathogens that are elsewhere, or just anything that kind of elicits the immune response elsewhere, that tends to happen in the nearby lymph nodes. So what tends to happen is, let me see if I have it on the next one.
Hello.
Yes.
Yeah, hello, ya masala alaykum salam. Abshir.
Okay, that's obviously not speaking to me. All right, So what tends to happen first, as Dr. Ahmed just mentioned a minute ago, how you have dendritic cells that are sampling around and doing the surveillance. And once there is the right environment, because I do say the right environment because typically you'd have either the pro-inflammatory or the activation of these dendritic cells to go into danger mode and get activated to decide to move into the lymph nodes and try to alert other cells and try to prime them. So what happens if we start off, hopefully you guys can see, oops. Hopefully you guys can see this. So on the far left, let me see, can you guys see the arrow when I'm moving it or not? Hello?
Yes, we can.
Clear.
Okay, all right. So when you look at the top corner, this is a dendritic cell that is already carrying an antigen and presenting it. This has already been activated. So it's gonna move to the lymph node, and this is where it's gonna come into contact with the T cells and potentially other cells as well. But to start off, let's say if it does come into contact with T cells, it's going to present the antigen via its MHC, but also it's going to have to provide this co-stimulation here. And these two are kind of necessary for it to be activated. And once it's activated, obviously one other addition thing. To start off, I think maybe Dr. Ahmed also mentioned, but you do have a plethora of clones that recognize different antigens. And this is when it comes to when we talk about the adaptive immune system and how it recognizes specifically different molecules. So in this case, you'd have to have a T cell that recognizes the same antigen that is being presented here on the MHC. You'd have the co-stimulation, and you'd have actually the CD4 that recognized MHC class 2, but that doesn't matter. And then accordingly, it can differentiate now, because in this case, it does recognize that it does need to kill potentially other cells, so it can differentiate into each one. I'm gonna just follow one single route here. So it's gonna differentiate into a T helper 1, which is the more killing, let's say it's this is the type of T helper cells that helps eliminate, or it's more of the pro-inflammatory. So the Th17 is pro-inflammatory, but it tends to be more involved in autoimmune. So I'm gonna follow through with the Th1 after it's already been activated, and it's gonna start to expand and proliferate. It's now gonna move into the vessels and try to go back to the source of the danger and get rid of the source of the danger. Excuse me. But these Th1, well, obviously the Th1s don't directly remember a kill, but rather they are going to produce cytokines and molecules that will help other cells to kill. This is just because example I'm talking about CD4, but similarly what happens here in this spleen, rather if you consider this not a CD4 positive cell, but rather a CD8 positive cell, they will also recognize antigen that is presented to them. They will also have the co-stimulation. They will also expand, and they will also go back to the source where the original exposure is, or where the target cells that you want to kill is going to be. So if we look at the different phases of cell-mediated immune response, first off, you have to recognize the antigen. And this would be first, as we said, is the APC, which do the surveillance. They have to recognize something that they think the body needs to respond to or attack, and not non-self. And then it's going to interact with the CD4 or CD8 cells. This is in the secondary lymphoid organs. And then once it is activated, it will start producing cytokines that feed back or can act as growth factors for the CD8 positive cells. And this will allow them to proliferate and for them to differentiate. And after they respond, some of the cells are going to go on and to become CD4 memory cells. And these are the cells that are going to last for years, if not a lifetime. And this is what will allow for future quicker responses upon second exposure. I am going to play this video and hopefully it comes clear.
Here we have a population of mature B cells expressing surface antibody and educated T cells with T cell antigen receptors on their surfaces. At any one time in a population of lymphocytes, there will be millions of different clones of cells, each carrying a different receptor, and therefore only able to recognize a particular type of antigen. This means that in a normal immune system, there is always a small subpopulation of cells which are able to recognize a specific antigen. If this were not the case, we would be completely unable to protect ourselves from pathogens. Such cells are said to share the same specificity. This is one of the reasons why lymphocytes circulate around the body to ensure the small number of cells which are able to recognize a specific antigen will actually come into contact with it. Consequently, most of the cells in the human body are never called upon to fight infection. They are simply there just in case they are needed to combat any new strains of pathogen that might enter the host. We are going to look at how B cells and T cells differentiate and the mechanisms which bring this about. Here we have a virgin lymphocyte pool. In the presence of an antigen, only one of these many different B cells is
I'm just going to skip over for T cells since somebody else will be talking about B cells. There we go.
Now we shall look at how T cells differentiate. The process is quite similar. Again, we have a pool of virgin lymphocytes. There are millions of different clones of T cells, each carrying a different T cell antigen receptor. In the presence of an antigen-presenting cell, such as a macrophage, only one of these many different T cells is able to bind to that antigen successfully. As we have seen, this is called clonal selection. The antigen-presenting cell interacts with the T cell and releases cytokines, such as interleukin-1, which cause the expression of interleukin-2 receptors on the surface of the T cell. There are also crucial interactions between pairs of co-stimulatory molecules on the surface of each of the two cells. In addition to being able to bind interleukin-2 using its new receptor, the T cell is now also able to produce its own interleukin-2, enabling it to stimulate itself. This ability to produce cytokines, which can act on cells of the type that produce them, is called an autocrine action, whereas producing cytokines, which stimulate another cell type, is a paracrine action. The interleukin-2 binds to the receptors on the surface of the T cell, triggering division. This causes the induction of new co-stimulatory molecules on the surface of the T cell. The T cell divides, and after 5 or 6 cycles, there is a gradual loss of the interleukin-2 receptor. This prevents the cells from receiving any positive signals to continue dividing. All of the T cells eventually lose their interleukin-2 receptors but retain their T cell antigen receptor. However, some of them also retain the signaling co-stimulatory molecules, and those become the memory T cells. As before, these cells are able to mount an effective attack against a specific pathogen in the event of future infection. Memory cells remain in the lymphatic system where they can live for many years. Other cells lose their co-stimulatory molecules and become effector cells, which migrate out into the surrounding tissue to participate in effective responses to eliminate infection. These cells die within a few weeks. Both B cell and T cell clonal proliferation is driven by the presence of antigen. As soon as the antigen has been destroyed, the whole immune response switches off, leaving more cells in the system sharing the same specificity than existed prior to the original infection.
Okay, I think we can move on to the next slide. All right, we're actually nearly wrapping up. So if we talk about the phases of the adaptive immune response, I did talk about different phases of the cell-mediated immune response. In the more general sense, because it does mention it in the video, but start off, we'll do a quick recap. So first, we're going to have the antigen presentation. And this is going to happen in the secondary lymphoid organs, remember, where the antigen presenting cell, potentially the dendritic cell, is going to interact with T lymphocytes and or the B lymphocytes that have the same specificity to the same antigen. So in the case of the T cells, the T cell receptors or TCRs, or in the case of the B cells, which my colleague will be talking about, it is the B cell receptor. And once that is recognized that, okay, we need to act kind of situation, that is when you're going to have clonal expansion. So the clone that is specific to this antigen is going to proliferate and expand, and then further differentiate into effector cells or plasma cells in the case of B cells. And this part is what we call the effector phase. And this is when it's going to go on to try to eliminate whatever elicited this immune response. Once it manages to destroy what it needs to destroy, an important part of the immune response is contraction or homeostasis. You do not want to have a continuous state of this heightened immune response or a pro-inflammatory response, because that is damaging, obviously. So what is the norm is this, one of the phases is you have to have this contraction or homeostasis, which involves the apoptosis of these cells that are no longer necessary. And I think it did allude to it in the video where after a certain level of expansion, it does also stop. But eventually, after it detects that the danger is no longer there, it does get switched off and or undergo apoptosis. And this may be aided in some cases by T regulatory cells that Dr. Ahmed mentioned earlier, in addition to other conditions and factors that would affect it. And then once you do have this all ready and happy and done, you will retain these memory cells that will help aiding in the response second time exposure. However, this memory can be detrimental in the cases of transplantation, because, and I think my colleagues will probably allude to it more, when the donor, for example, has memory immune and cells that can recognize things that are potentially within the recipient. So these can result in a hyperacute or very quick response. Am I with time? All right, I'll move on for the sake of time. So, okay. So this is just, again, I believe my colleagues will go into more detail. But this is where, again, an example we have, this is the donor dendritic cell that can potentially travel and be recognized directly by T lymphocytes. And then they could go back and cause their destruction, in addition to destructing them here. But now this have been activated. And one of the things when it comes to APCs, typically when they're just doing surveillance, they are not activated. They would not be able to produce the co-stimulation necessary for T cells. But it's been hypothesized that with the damage of surgery, and when you're excising the organ from the donor, that in itself can activate these donor dendritic cells. On the other hand, you can have recipient dendritic cells being involved, and those can end up sampling the donor alloantigens, the antigens which they recognize as non-self, and that is when it can again sensitize and activate and prime T cells in the lymph organs, and that would result in mounting an immune response. In the case of the CD4, that would potentially result in their production of cytokines. I need to wrap up. Okay. So that is the main gist. Actually, this is the last slide. So this is more of an introduction, and I think my colleagues will go into more detail and in respect to the rejection. Thank you.
Thank you very much, Dr. Nada. Anybody has questions? We have 2 minutes, please. Anybody?
Assalamu alaikum. This is Dr. Syed. I have a question from Dr. Nada. what is the life of the memory cell? Does it stay lifelong, or does it vanish after a period of like 5 years, 10 years, or no, it stays for lifelong? Thank you.
Well, you do hear them say that it's lifelong, but it's not always the case. But it is often said that it is lifelong, I have to say.
Thank you.
Any other questions? Another question? Okay, very well. Thank you, Dr. Nada. Well done. Thank you for being on time and nice presentation.
Thank you.
So now